Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 5, Negative Exponents and the Laws of Exponents. So the first classwork, we're going to start with the definition. And it says, for any non-zero number x. So what that means is the base cannot be 0. Because anything 0 to any power equals 0. 0 times 0 times 0 times 0 times 0 is 0. 0 to any power is going to equal 0. Actually, there's going to be a problem here because 0 to the negative 1 would put 0 in the denominator, and then that's dividing by 0, and that is undefined. So we can't have x equal to 0 because it's going to end up in our denominator. All right, and then it says for any positive integer n. And the reason n is positive is because we're trying to figure out what to do with a negative exponent. So if I have 5 to the negative n, and then n is a negative number, then I would replace it with, say, negative 3. Then a negative negative becomes a positive, because a negative times negative is positive, and then the rule doesn't come into play because we're dealing with a positive exponent. So n has to be positive. Okay, so that's the reason for those two statements. All right, so continuing on, it says, note that this definition of negative exponent says that x to the negative 1 is just the reciprocal 1 over x of the original x. So that's the inverse or reciprocal. As a consequence of the definition, for a non-negative x and all integers b, we get x to the negative b equals at 1 over x to the b. So all they did here was changed n to b. Okay, so let's work on exercise 1. It says verify the general statement x to the negative b equals 1 over x to the b for x equals 3 and b equals negative 5. So the first thing I'm going to do is just rewrite the statement or the equation and then substitute in the variables that they told us. So x is 3, and I have an x right here and an x right here. So that's going to be 3 replacing the x. And then b it's negative b, so I'm going to put a negative sign there. But b is negative 5. So if just b by itself, without that negative, is negative 5, then we're going to end up with this. Okay? And that is going to equal 1 over 3. And what I'm doing is getting rid of this green negative sign first. And that's going to leave me with this negative 5 here, because the negative tells me to move it to the denominator. That's what the rule says. But now I have a negative in the denominator. So what that means is I'm going to take the reciprocal of the denominator, so I could show it as this, 1 over 3 to the power of positive 5. Because the negative 5 is telling me to put it in the denominator of this number 3, and we could always think of that as 3 over 1. But now we have 1 divided by 1 divided by 3 over to the 5th, and that is going to equal the 1, my numerator, times the reciprocal of this, 3 to the 5th. Let me keep my colors here. 3 to the 5th over 1, which is simply 3 to the 5th. Okay, this rule here comes from last year. Remember that you can't multiply a fraction by a fraction, and the rule says to flip it and switch it. Okay, flip the fraction and switch it to multiplication. So you flip the denominator and switch it to multiplication instead of division. Okay, there is another way to look at this, by the way. If I know that 3 to the negative 5, I know that a negative times a negative is positive, I can just do 3 to the 5th power, because a negative times a negative is positive, and just in one step we're getting to that. But I wanted to explain to you what the negative is doing. It's flipping It's making this go into the denominator, and then it's making this one go into a denominator, and then the rule of multiplying by the reciprocal when we have a fraction. Okay, so now we're moving on to 3 times 10 to the negative 2. So in this exercise, what we want to do is change that to 3 times, and then this negative 2 has to become a denominator, so I'm going to draw a fraction, and I'm going to put the x down below, and this negative right here is going to become positive, so it's 3 times 1 over x squared. I'm sorry, not x, 10. This 10 to the negative 2 is going to become 10 squared. So when I multiply across, I can think of 3 as 3 over 1. 3 times 1 is 3. 1 times 10 squared is 10 squared. And 10 squared is 100. 10 times 10 is 100. And I can write this as a decimal. Just by saying it, you're saying the decimal. 3/100ths. So that's 0.03. 10th, 100th. So the answer is 0.03. So what this really is a scientific notation telling you to move the decimal point over 2 places. Okay, but we're using the rule of exponents here, not the scientific notation. So I'm going to stick with that. So now you try these number exercise 3, pause the video, see if you can do it, and then come back. Okay, so here we go. 3 times 10 to the negative 5. I'm going to put 3 over 1. I'm going to multiply by, I don't like x's, so I'm going to change that to a dot, so it looks like a variable. And 10 to the negative 5 is the same as 1 over 10 to the positive 5, because that negative right here says to put it in the denominator and get rid of the minus sign. Multiply the numerator times the numerator. Multiply the denominator times the denominator. 1 times 10 to the 5th is still 10 to the 5th. And 10 to the 5th is 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000, times 10 is 100,000. 10 to the 5th is 100,000. So if I do 10th, 100th, 1,000th, 10,000th, 100,000. So there's my decimal. Okay, in exercise 4, it says write the complete expanded form of the decimal 4.728 in exponential notation. And it's going to be expanded. And that means a bunch of addition. So I'm going to use parentheses here, and I'm going to all color code this. So the 4 is in the 1's position. And if I want to multiply it by 10 to a certain power, that's what exponential notation is, times 10 to a certain power. Well, 4 times 10 is 40. So this is obviously not going to be 1. So I have to ask myself, 4 times what will give me 4? So we should all know that 4 times 1 is 4. And to get 1, it's a number to the power of 0. 10 to the 0 is 1. 4 times 1 is 4. So there's my first position. And then I'm going to add. And now I'm going to deal with the 7. So I'm going to put a 7 here. And I'm going to multiply by 10. And 7 times 10 is 70. 7 times 10 to the 0 is 7 times 1, which is 7. That's not right. But if 7 times 10 to the negative 1 is 7 times 1/10, which is 7/10ths, and that's my 10ths position, so that is going to be my 10ths position value, negative 1. So there's a pattern here. What's going on is, now I'm going to use blue here. Now we have a 2. So I add a 2 times 10 to a certain power. 10 to the 0 is 1. 2 times 1 is 2. That would put it where the 4 is. 2 times 10 to the negative 1 is 2/10ths. That'd put it where the 7 is. 2 times 10 to the negative 2 is going to be the same as 1 over 10 squared, which is 1 over 100, which is 100th position. And I'm going to go back and do that for this. This means 1 over 10, which is 1/10. 10th position, 100th position. Okay, hopefully you see the pattern here now and are understanding what to do next. And now we do plus, put the number that is in the position, times 10, and this time it's going to be to the negative 3, because 10 to the negative 3 is 1 over 10 to the positive 3, which is 1 over 1,000, which is 1,000th, 8 1,000ths. So this is the expanded form of 4.728. Okay, now for exercises 5 through 10, write an equivalent expression in exponential notation to the given one and simplify as much as possible. Okay, so try these on your own. Pause the video, come back and see how you did. Okay, so 5 to the negative 3 tells me to put this 1 over 5, make that negative 3 a positive 3, which equals 1 over 5 times 5 is 25 times 5 is 125. I'm going to take this a little bit further. Okay, this is the answer, 1 over 5 cubed, but 5 cubed is 125. Now, if I put that in my calculator and I do 1 divided by 125, I get 0.008. Okay, now if I went out to expand it, didn't ask for it, but I'm just giving you another example of that expanded form, then I'd say this is 8 times 10 to the negative 1, 2, 3. Okay, so look at what happened here. 5 to the negative 3 is equivalent to 8 times 10 to the negative 3, and I can verify that with my calculator. So let me move this over here so you can see both things. So if I put in 5 to the power of negative 3, I get 0.008. If I put in 8 times 10 to the power of negative 3, then I'm going to get the same 0.008. Okay? All right, exercise 6, 1 over 8 to the 9th power. Now, there's two ways I can do this. This is trying to teach, so I'm not going to do this anymore. All we're going to do is in exponential notation to the one given. So what they're trying to tell us is we don't want to have a fraction here, so I'm going to change this to 8, and since the 9 was positive and I'm flipping it, that's going to change it to negative 9. We're working backwards on this one. So 8 to the negative 9 equals 1 over 8 to the positive 9. Exercise 7 says 3 times 2 to the negative 4. Think of that as 3 over 1 times, and then the negative 4 is only going to the 2. So this is going to be 2 to the positive 4 now. 3 times 1 is 3 over 2 to the 4, which is 3/16, but I'll just leave it in exponential notation. Okay? So this is the answer here. In exercise 8, it says let x be a non-zero number. X to the negative 3 is going to be equal to 1 over x to the positive 3, and we are done. Exercise 9, we have a fraction that is equivalent to x to the negative 9. Positive becomes negative when we get rid of the fraction. And then finally, we have x, y being two non-zero numbers, because if either one of those were 0, the whole answer is going to become 0. So these are not 0. X times y to the negative 4. There is no parentheses here, so the negative 4 is only the power of y, not the power of x. So I'm going to rewrite this as x over 1 times y to the negative 4 over 1 for starters. And then I'm going to flip the one that has the negative. So now it's going to be 1 over y to the positive 4. Now when I multiply x times 1, I get x. Multiply 1 times y to the 4th in the denominator, and I get x over y to the 4th. Okay, so now moving along, we're reviewing here. It says we accept that for non-zero numbers x and y and all integers a and b, x to the a times x to the b equals x to the a plus b. So when we're multiplying two bases that are the same, we add their exponents. The next one is x to the b to the power of a. That's the power rule, and what that says is if we have a number x to the b raised to the a, then we multiply b times a, and we get x to the power of ab. And then the last one is a quantity in parentheses to the power of a. the a is going to get distributed to the x and the y. And we get x to the a, y to the a. So now with all that said, we're going to claim that x to the a divided by x to the b, the rule says that we're going to subtract exponents. It's going to become x to the a minus b. And if we have a fraction in parentheses, the a, the power, will get distributed to the numerator and the denominator and give us x to the a over y to the a. So now we're going to use these rules. I'll leave those right there. And I will do, if you want to try these now after that explanation, see if you can do the exercises 11 through 14. Pause the video and then come back. Okay, so here we go. I have a base 19, I have a base 19 being divided, so the base is going to stay the same. I have a 2, I have a 5. The rule says it's the numerator power minus the denominator power. And when I simplify that, I get 19 to the negative 3. I could also rewrite that as 1 over 19 to the positive 3. Exercise 12 says 17 to the 16th x and 17 to the negative 3. Okay, so my bases are the same, so I'm going to keep my base. I'm going to take the numerator power and I'm going to subtract the denominator power. Be careful here, it's a negative, so minus a negative is plus. So this is going to be the same as 16. Let me rewrite that. Base 17, power of 16 plus 3, and that is going to give me 17 to the 19th power. Careful with those negatives. Minus a negative is plus. Exercise 13. If we let b equal negative 1 in 11. Okay. This one here is going back up to, way up to 11. Example exercise, where is it? Okay, it's not in yours. So what they're talking about here is the rule in the teacher edition that says that we have, okay, this was rule 11 from above, and it says if we let b equal negative 1, so here's my b, that's my exponent, so I'll just put that right here, a be any integer, so now I'm going to put the parentheses here, a is any integer, so I'll just leave that a is any integer, and y is a non-zero number, so y is going to be our base. We're going to replace the base with y. What do we get? So what they're asking is, if y is any base to the power of negative 1 times another power of any number, what are we going to get? And it's going to be y to the negative a, which is going to be the same as 1 over y to the positive a. Okay, exercise 14. Show directly that 7/5 to the negative 4 equals 7 to the negative 4 over 5 to the negative 4. Okay, so what I want to do here is 7 over 5 to the negative 4 equals 7 over 1 times 1 over 5 to the negative 4. I can split fractions up like that. When I multiply these back together, 7 times 1 is 7, 1 times 5 is 5, so this is okay. Okay, so if I split it up like that, and then flip them, so that's going to equal 7 times 5 to the negative 1. Okay, so I'm just flipping this fraction. So I want that 5 to be in the numerator. It's 5 to the negative 1. So now that's all I've changed. 7 over 1 is still 7. 1 over 5 is 5 to the negative 1. And take that to the negative 4. Then I'm going to distribute, and I'm going to get 7 to the negative 4 times 5 to the negative 1 times negative 4, which is a positive 4. And then finally, I'm going to write that as 7 to the negative 4 divided by, now I'm going to flip this back over, and that's going to be 5 to the negative 4 in a denominator. So whenever you're moving this from a numerator down to a denominator, the sign changes. Okay? So an integer turned into a fraction is the reciprocal. And when I turn it into a reciprocal, the exponent has to change. And we just proved that this is equal to this. That was our outcome. Might be a little confusing to you, but this is the proof to get from here to here. That is the end of lesson 8. Go do your problem set.